So this is the Boulder Advanced Robotics Lab in the Computer Science Department at CU. I'm the director, the PI of the Autonomous Robotics and Perception group here. And what we focus on mostly is experimental robotics, building platforms that actually can autonomously navigate and do things in our environment. And there's some self-driving car implications with that too. We try to use small ground vehicles for the most part in order to explore new spaces and do work with the Department of Defense, National Science Foundation. We have folks that work with NASA, Department of Homeland Security, agriculture, and some companies as well.
We're working on automating walnut harvesters, which is kind of a cool idea and also presents some really interesting challenges because we normally use visual inertial state navigation algorithms, which basically fuse together data from cameras and accelerometers and gyroscopes to allow the robot to develop a picture of where it is. But the walnut harvesting process presents a pretty big challenge for that because it's basically sweeping walnuts up off of the dusty ground, so it kicks up a lot of dust into the air, which can block the information coming in from your visual sensors, your cameras. So we're having to find ways around that. And that's one of the really cool things about this project particularly is we're working on a very concrete problem with an immediate application. So it gives you it gives me a pretty good feeling of accomplishment when we make progress on it because there's a very concrete goal. It's not just, write a paper in time for this deadline. It's, can we pick walnuts up off the ground autonomously?
One of the projects that I'm working on right now is associated with how we can verify controllers on autonomous vehicles. It might sound kind of obvious, but in fact it's not. A lot of the ways that, for instance, autopilots have worked for a long time is they work on these linear controllers. They tend to be controllers that can be verified from the outset without having to consider everything that happens. Now what we see today are a bunch of learning-based controllers. So using machine learning and deep learning, we're seeing a bunch of new ways in which robots can actually synthesize what they want to do in the moment. And unfortunately, what that means for us is that there's no way that we can really tell based on their experiences how they're going to behave, just like a human, right? But that doesn't really work for safety critical systems. We want to know exactly what they're going to do when we start fielding them. We don't want to leave that up to chance. And so one of the projects that we have going on today is National Science Foundation funded research in how to make verified autonomy in cooperatively driving vehicles. We've built our own ground vehicles that are these small platforms, 1/8 scale cars. They have the same basic physics as what a car would have, and they allow us to be able to play with new controllers in lab setting and then roll those sorts of controllers and planners out to real cars. We could build a car, we have in the past even sort of jury-rigged a car and put all these new controllers into the steering wheel and the gas pedal and the brake and everything. That is extremely expensive and time-consuming, so it's nice just to build our own platform. And in fact, that one small platform gives us enough challenges as it is to test out our algorithms. There's a foundational problem still in robotics about how we do those verified controllers, which is one of the things that we focus on. But a lot of the capabilities that we have on the vehicle tend to be very aggressive maneuvers. So what happens if you needed to really quickly turn in order for you to avoid hitting something, for instance? So collision avoidance is a real challenge. That's something that we're currently developing and something that we can do in the lab. And if the car rolls over, it's not the end of the day, right?
For this department and this laboratory in particular, I really like being here because it allows me to work on computer science, like algorithmic problems, but still also work on physical hardware. My background's in mechanical engineering, so I always like being able to turn wrenches and build things.
Really, it's all about trying to make robotics more accessible to companies and to the government, as well as just people, trying to actually see why there aren't robots in the spaces that we live in right now, and then solve those challenges as we get to them.